welcome and welcome back. So we are reviewing units and unit conversions today. Dimensional analysis is how we take a value with a given unit and change the magnitude of the value without changing the meaning of the value by changing the units, such as if we know that something is 12 inches long and we know that something else is 1 foot long, those have different magnitudes, 1 and 12, and different units, uh, feet and inches, but the result is that they're the same length. So dimensional analysis helps us deal with this idea. So let's dive in. Now, I think the most important thing to start with is to ask ourselves, are units even important? Why are we learning about this? Well, then I would ask you, please, may I have 7? And if you say 7 what, exactly. Now, really, math classes are the only place that we don't care about units, but in life, we absolutely do. I have 7 in my room. Dollars? Good for you. $1,000,000? Even better for you. Angry goats? Not so great. So the unit that comes with the number is just as important, if not maybe more important, than the value itself. So in science, we use the metric system of units. The metric system are units that are based on the decimal-based system, so they vary by orders of magnitude of 10. And also, all of the units are trying to have a physical relationship with the world, and that's based on a conversion that a group called IUPAC, which is the International Union of Pure and Applied Chemistry, made the decision that all the units are based on physical constants, so something in the world or in the universe that never changes. So our metric units, our mass is the kilogram, length is the meter, time is the second, temperature is Kelvin, and the amount of substance, chemists, we always work in moles, so we're going to talk a lot about moles. So just a little bit of information about these units and what they mean. So originally the kilogram back in France when the metric system was invented was a cylinder in 1889 of platinum and iridium, and that was stored in very safe conditions and used to calibrate all other scales to what a kilogram meant. But now we use Planck's constant, again in that change that IUPAC made in 2019, using the mass energy equivalent of Planck's constant. The meter originally was defined as the Earth's size, 1/10,000,000th of the distance between the equator and the North Pole. But again, now we've, in 2019, moved it to the distance. 1 meter is the distance that the light travels in a vacuum in 1 over about 300 millionth of a second. That's the exact number there. You'll see that there's no volume metric here because we use the cubic meter as a metric of volume. And so 1 cubic meter is also equal to 1,000 liters. And these are some important conversion factors. 1 milliliter is 1 cubic centimeter, or 1 cc. If you ever watch medical shows and they say, give me 10 cc's of some medicine, stat. They really mean 10 cubic centimeters, which really means 10 milliliters. And then also 1 liter is 1 decameter cubed. And if you're asking yourself, what's a milliliter centimeter cubed and decameter cubed? Well, we'll get to that in just a second. But let me tell you a little bit more about units. The second historically was derived as 1/86,400th of a day. So that's how many seconds are in a day. But now we use the hyperfine transition frequencies of the cesium-133 atom. And so if we haven't really talked a lot about the quantum nature of atoms, well, stay tuned. We'll talk about it later in upcoming classes. But for now, we know that the second is correlated to a physical constant in the universe. The Kelvin is named after William Thomson, the first Baron Kelvin, who lived 1824 to 1907. The important part about the Kelvin scale is that the absolute zero, the lowest possible theoretical temperature where there is no atomic movement is 0 Kelvin, absolute zero, which means that every value in the Kelvin scale is positive, which has implications in the math that we do, which is why we use Kelvin scale. And finally, the mole was historically 12 grams of carbon-12, but now has been redefined as a constant, which is Avogadro's number, exactly 6.0221407.6 times 10 to the 23rd. Elemental entities, or atoms, molecules, ions, however you are collecting your atom groups, it's that times Avogadro's number of the substance, and that's a mole. So that's my review on units. Now, the metric system uses prefixes that are based on the decimal system, a 10-base system, so that we can amplify or reduce the value of our unit by orders of 10. And so you'll see that if we start at our base unit, which has a conventional notation of 1, if we increase the values by an order of magnitude of 10, then we have, let's say, we start with 1 gram, then we have 1 decagram with a K. Decagram is 10 grams then. Hectogram would be 100 times that, so it would be 100 grams, or 1 times 10 to the second grams. Kilo, which is something we'll see a lot, is 1,000 of a unit. So a kilogram would be 1 times 10 to the third, or 1,000 grams. We'll jump a few orders of magnitude to mega. Mega with a big capital M is 1,000,000 times 10 to the 6 grams. So 1 megagram is 10 to the 6 grams. Giga is 10 to the 9th, or a billion. So 1 gigagram is 10 to the 9th grams, and tera is 10 to the 12th grams. If we reduce by factors of 10, we will see desa, right? So deca is 10 times, desa is 10 divided by 10, 0.1 amount. And so we have, if we're now looking at the base unit of meters, 1 decimeter would be 1 times 10 to the negative 1, or 1/10 of a meter. A centimeter is 1/100th of a meter. There is 100 centimeters in 1 meter, or 1 centimeter is 1/100th of a meter. Same thing with millimeter. There is 1,000 millimeters in 1 meter, or 1 millimeter is 1/1000th of a meter, 1 times 10 to the negative third meter. Micro, this is the symbol mu, and it stands for micro, which is 1 millionth. So 1 times 10 to the negative 6. So 1 micrometer is 1 times 10 to the negative 6 meters, or there is 1,000,000, or 10 to the 6 micrometers make up 1 meter. A nanometer is 1 billionth of a meter. Often we use this to measure light, and that means that there is 1 billion nanometers in 1 meter, or 1 nanometer is 10 to the negative 9 meters. And you can see the same thing with pico and femto, lowercase p and lowercase f, which are 10 to the negative 12th and 10 to the negative 15th. Very small. So 1 picometer and 1 femtometer are extremely small, 10 to the negative 12th meters and 10 to the negative 15th meters, respectively. Obviously, these aren't the units that most of us grew up with. We grew up with traditional units. Originally, units were regional, and how people defined length, width, and volume has to do with just their experiences. Things like English units derived from tradition, the foot, gallon, yard, bushel, stone. These are all units that had meaning, but no longer have such relevance. And so we try to change to metric units, which relate to standardized values with scientific meanings. And so as a result, we need to use conversion factors, which are employed to unify traditional units to our SI metric units. And so here are some of the examples. 1 mile is 1.609 kilometers. yards to meter, feet to meter. These things are important with distance. And inches to centimeters. This is 2.54 exactly centimeters in 1 inch. Feet cubed to meters cubed for volume. 3.785 decameters, which is the same thing as 3.785 liters, are in 1 gallon. Quarts to decameters or quarts to liters here. And pounds, 2.205 pounds make up 1 kilogram. So these are going to be important as we take values from our traditional units that were given, but change them into metric units so they make more sense for our math. This is the conversion guide that I've prepared and made available to you. I recommend making sure you stop this video right now. If you don't have this unit conversion guide, print it out, have it available to you, because we'll be referring back to it throughout the video and then throughout the assessments, the practices that you're going to do upcoming. So this is going to be a great tool for you, not just in this boot camp, but going forward into class. So finally, it's important to know that we're using conversion factors to change one unit into another unit, but the value of the unit is not changing. And the only way that we can multiply something or divide something by a value and not change it is to multiply or divide by 1. And that's what we're going to do. A conversion factor is a ratio that equals 1 that just has 2 units, as I mentioned earlier. 12 inches and 1 feet are the same value, but with different units and different magnitudes. And now we know 1 inch and 2.54 centimeters are the same value, but with different magnitudes and different units. And so every conversion factor is going to be a ratio that equals 1. If you go 5,280 feet and you are racing somebody that went 1 mile, you traveled the same distance. So when we set up our conversion factors, our goal will be to take what we're given with the units that we're given, set up a conversion factor that equals 1, with the unit that we do not want in the denominator, while the unit that we want is in the numerator, such that our given unit cancels, leaving only our desired unit, which is what comes out in the end. Now, again, this is only talking about units. It's not talking about numbers. It's not talking about the values that were given in this conversion factor. It's just lining up units to make sure that what we don't want cancels numerator and denominator, and that what we want is left in the numerator or the denominator as necessary. And then finally, when we execute our math, if we find a number in the numerator, we're going to multiply our original value by it. If we see a number in the denominator, we're going to divide our original value by it. Okay, that's a lot of information. Hopefully some of this is reminder, but let's dive into it and see what it looks like. How many milligrams are in 2.54 grams? So here's going to be our approach. First of all, we need to know the relationship between milligrams and grams. So use this conversion guide. It has all the prefixes here. So we can go down to milli and we could say, oh, there's 10 to the negative third meters in 1 millimeter. So this is the conversion factor that we're going to need. So here's the 3-part strategy that we're going to use today. First, we're going to make a plan. We want to go from grams to milligrams. And we know that this is a ratio of 1 to 1,000. There's 1,000 milligrams in 1 gram, or 1 milligram is 1,000th or 10 to the negative 3 grams. You can look at them either way. Now we're going to set up the conversion factors. Where do we start? We start with what we know. What we know is that there's 2.54 grams. And then we're going to set up a conversion factor, a ratio that equals 1, that relates grams to milligrams. So how are these things the same? Well, when we have 1 gram, we have 1,000 milligrams. And so then our grams cancel and our milligrams comes out. As long as this relationship is true, then to complete the arithmetic, if we see a number on the top, we multiply. If we see a number on the bottom, we divide. So 2.54 divided by 1 is 2.54 times 1,000 is 2.54 times 10 to the third milligrams. So 3 steps: make a plan, what we want our units to do, and identify using our conversion guide how those things relate. Then start with what we know, set up our conversion factor such that the units in the numerator and denominator cancel, make sure that the values inside equal 1, and then to execute the arithmetic, we multiply any values that are on the top and divide any of the numbers that are on the bottom, and we get our answer. Let's try another one. How many meters are in 3.57 times 10 to the 11th nanometers? So we want to go from nanometers to meters. So again, let's take a look at our conversion guide. We have nanometers all the way down here, and it's 1 billionth of a meter. There is 10 to the 9 nanometers in 1 meter, or 1 meter is 1 times 10 to the negative 9th meters. We can set our conversion up a little bit different this time just to show you that no matter how we perceive, whether it's 1 billionth of a meter or a billion nanometers in 1 meter, we'll get the same answer. So let's solve this. First, we're going to make a plan. We want to go from nanometers to meters. And we can say that 1 nanometer is 10 to the negative 9th meters. A little bit of a whoopsie there. So we can say that it is a billion nanometers or 1 meter. So set up our conversion factors, start with what we know, which is 3.57 times 10 to the 11th nanometers. Now set up our conversion factor. So nanometers is going to go away, meters is going to come out, and there is 10 to the negative 9th meter is 1 nanometer. Or you could say 10 to the 9th meters, a billion nanometers, is 1 nanometer. But either way you set up this conversion factor, it will work as long as nanometers cancel with nanometers, and this conversion is 1. It does help to remember a nanometer is very small, and a meter is about a yard. It's pretty big. So when you're asking yourself which is bigger, which is smaller, make sure that agrees in the way that you're assessing your values. So when we multiply this, we get 357 meters. 3.57 times 10 to the 11th times 10 to the negative 9 meters in 1 nanometer, we get 357 meters. Let's try another one. How many centimeters are in 12 inches? So now we're not just using prefixes anymore, but we're going to want to get a lot of practice with those prefixes. Now we're saying we're given a traditional unit and we want to convert it to an SI unit. And so here we have the relationship between inches and centimeters. It's an exact value. There's 2.54 centimeters in every 1 inch. So that's where we're going to be going on our conversion guide. So let's make a plan. We want to go from inches to centimeters. And there is 2.54 centimeters in 1 inch. That's what our conversion guide has told us. And so we're going to start with what we know in setting up our conversion factor, which is 12 inches. And then we want inches to go away. We want it to cancel, and we want centimeters to come out. We go back to our conversion guide and remind ourselves that there is 2.54 centimeters in every 1 inch. Inches cancel with inches, and centimeters comes out as the unit that we want. And so then we take 12 divided by 1 is 12 times 2.54 centimeters, and that should equal 30.48 centimeters. So make sure that you're getting those values in your calculator, but when you multiply 12 by 2.54, you should get 30.78 centimeters. Let's try one more. This one might be a little tricky. Let's see what we can do here. How many liters is 15.5 gallons? So we have 15.5 gallons. We want to know how many liters. So here I have gallons to decameters. I don't have gallons to liters on my list. But down here, I have 1 decameter is 1 liter. I can make an instant change, but let me just be a little bit fastidious and show you how I would do this. All right, so I want to go from gallons to liters. But I'm getting stuck by decameters cubed. So let me just work with all of it. Oops, that says grams, gallons. So if I have 15.5 gallons, and then there is 3.785 decameters cubed in 1 gallon, I could set up another unit conversion right next to it and say, well, 1 decameter cubed is 1 liter. Now let's check these units. Gallons cancel with gallons. Decameter cubed cancels with decameter cubed and leaves liters out. Of course, we're dividing by 1 and multiplying by 1. So this isn't a very exciting unit conversion, but it does change us from cubic volume to liters, and we get 58.7 liters. When we multiply 15.5 times 3.785 divided by 1 times 1 divided by 1, we get 58.7 liters, which brings up an interesting idea. We can do multiple conversion steps simultaneously as long as we know that the unit we're given cancels on the denominator, and then the given desired unit in the numerator further cancels with another denominator, and everything canceled until the unit that we want comes out. And we can do this with 2 conversions, 3 conversions, 4 conversions, and that's really just as much as I could fit on this slide. But you could ostensibly do this infinitely, but you'd be really bored for the rest of your life doing arithmetic. But let's try some multi-step conversion factors. Here's one. It should be kind of easy, but let's see. How many milliseconds are in 3 years? Well, milliseconds are hard for me to kind of conceptualize, but I know that they're in the movies, and especially when they're trying to defuse a bomb, milliseconds are important. So we're going to go to our conversion guide and remember that milli, regardless of what the base unit is 1,000. There is 1,000 milliseconds in 1 second, just like there is 1,000 millimeters in 1 meter. But we got to get to seconds first from years. So my plan is going to be, I'm going to go from years to days, because I know that conversion factor. If I live 1 year and my daughter lives 365.25 days, don't forget about that leap year, we have lived the same period of time. And I could go from days, I could break it down, I know hours, and then I could go from hours to minutes and minutes to seconds. And then I can go from seconds to milli, small m, seconds because there is 1,000 milliseconds in 1 second. And I think the rest of these we can probably figure out. So let's set up our very grand unit conversion now, but see how much it makes sense. So start with what we know, which is 3.0 years. There is, in every 1 year, 365.25 days. So years cancel with years and we get to days. Now we want to get to hours. So we want days to go away and we want hours to come out. And I know that there is 24 hours in every 1 day. And then I want to go to minutes. So I want hours to cancel and minutes to come out. And I know that there are 60 minutes in 1 hour. If you work on unit conversions for 60 minutes and I work on unit conversions for 1 hour, we've worked on unit conversions for the same amount of time. Now I can go to seconds. I won't belabor the point. In every 1 minute, count them up, there's 60 seconds. So minutes cancel with minutes. And now that one maybe strange conversion factor, but seconds are a base unit of the metric system, which is a 10 base system. And remember, in the bomb diffusing scene of the movie, they worry about milliseconds, so it's a real thing. In every 1 second, remember, there is 1,000 milliseconds. Seconds cancel with seconds and milliseconds comes out. And so we take 3 times 365.25 times 24 times 60 times 60 times 1,000. And I have, with 2 significant figures, 9.5 times 10 to the 10 seconds. All right, let's try another one. How many micrometers is 0.733 millimeters? So here we have we have millimeters, and we want to go to micrometers. And we know the relationship that there is 1,000 millimeters in 1 meter. And we know underneath it that there's 1,000,000 micrometers in 1 meter, but we don't have a conversion factor that goes from millimeter to micrometer. And so in this case, there's a couple ways you can approach it as a student, but I would say the safest way is to just go through each individual step that we can, which would be going from millimeters to our unit, base unit, which is meters, and then from our base unit to our desired unit, which is micrometers. And we know that there are 1,000 millimeters in 1 meter. And in 1 meter, there is 1 billion micrometers. So that's the relationships that we have. So let's set up the conversion factor, starting with what we know. There is 0.733 millimeters. And we want to go from millimeters to meters. There are 1,000 millimeters in 1 meter. Millimeters cancel. And then we set up our next conversion factor. We want meters to go away, and we want micrometers to come out. And in 1 meter, there is 1,000,000 10 to the 6 micrometers. And meters cancel, and all that's left is micrometers to come out. And so we have 0.733 divided by 1,000 and times 1,000,000. So we get 733 micrometers is 0.733 millimeters. So if it's not convenient or you don't see a way to simplify these conversion factors, then I recommend just doing a multi-step conversion factor and using all those prefixes to get you where you want to go. How many centimeters are in 1 mile? So here we're going to go with a mile. and get to our metric unit of kilometers. And then once we have kilometers, we know that in 1 kilometer is 1,000 of the base units. So 1 kilogram is 1,000 grams, 1 kilometer is 1,000 meters. And if we want to go to centimeters from there, there is 100 centimeters in 1 meter. So that's how we're going to go. So we're starting with miles. And we can go using our conversion factor to kilometers, to meters, and to centimeters. And there is, in 1 mile, there was 1.609 kilometers. In 1 kilometer, there's 1,000 meters. And in 1 meter, there's 100 centimeters. So those are our conversion factors that we get from our conversion sheet. That's our plan. So let's set it up. Start with what we know. 1 mile. And make sure that the miles cancel. For every 1 mile, there's 1.609 kilometers. Then we want kilometers to go away. And we can go to our base unit meters, knowing that there's 1,000 meters in 1 kilometer. It's a pretty long distance. And we know that centimeter is much smaller than a meter. And so in every 1 meter, there's 100 centimeters. And we take 1 mile times 1.609 times 1,000 times 100, and we get 1.609 times 10 to the 5th centimeters. Miles cancel with miles, kilometers with kilometers, meters with meters. 1 times 6.09 times 10 to the 3rd times 10 to the 2nd is 1.609 times 10 to the 5th centimeters. All right, so that is the basics of unit conversions, both single and multi-step unit conversions. So I'd like to take a break now and go to our simple conversion practice in Canvas and see if we can accomplish those tasks before we continue with our conversation about unit conversions in a more complex way. So why don't you take a break now, go do those. When you're finished, we can come to the second video and do some more advanced unit conversions.